Hi everyone, this is Piyush. Today we are talking about media types. By the end of this video, you will know what is media type and how it can be leveraged to improve your RESTful API design. If you're completely new to REST APIs, I'll highly recommend you to go and check my other video on Introduction to REST. I'll leave the link in the description below. So, without wasting any more time, let's dive right into the world of RESTful APIs. The term REST was coined by Roy Fielding in his PhD dissertation in year 2000. Actually, REST is an acronym for Representational State Transfer. The core construct in REST is a resource. Now, what is a resource? Resource is just a concept that can be referenced to using an identifier. For example, today's weather in London. In Roy Fielding's words, a RESTful API should spend almost all its descriptive effort in defining the media types used for representing resources. Okay, so as per this definition, media types are a big deal in designing a RESTful API. What are these media types? Media types provides open and extensible data typing and type negotiation. In simpler language, it defines both a data format and a data model. Let's try to understand media types using an example. Let's just say I have an API that gives me today's weather in London. Now, we have a website that wants to get weather details in HTML format to show to its users. At the same time, there is another mobile app that wants to get the same detail in JSON format. And we also have a legacy application consuming our services, and it can only understand XML format. In this example, weather is a resource, and these are just different representations of the same weather resource. And to identify each representation, we use media type. So the first one's media type is text HTML, second one has a media type of application JSON, and the third one is text XML. But technically, these are just different formats used to transfer the same information. Now, let's make things a little interesting. Say, we have another client which needs more details of weather resource in JSON format. As you can see, the detailed representation is different from the summary one. Let's call them weather summary and weather details. I would like to highlight one thing here. The new detail model is not backward compatible. Check the location attribute. For summary, it is a simple string, whereas for detail, it is an aggregate of name and geo coordinates. So now, we have two different models. Both needs to be rendered in JSON format. Now, just by using the standard media types, application JSON, the client can't differentiate if it's dealing with the summary or the detailed model. So, we'll have to define a custom media type which defines the model along with serialization format. Here, weather summary will become application/vnd myog weather summary plus JSON, and the detail will be represented by application/vnd myog weather details plus JSON. These are called vendor media types. They are more like fully qualified names for your model. Now, in this example, we are dealing with two variations of the same resource, but the same principles can be applied to API versioning as well. Whenever there is a breaking change in the model, we can declare the new media type with version information. This allows us to continuously deliver changes with backward compatibility and ensure that none of the existing clients are broken due to the new breaking change in our API contract. Okay, now let's take a step back and try to understand media type conventions. Let's start with standard media types. The convention is type/subtype. Some of the examples of registered types are text, application, image, video, audio. Subtypes typically consist of media formats like HTML, JSON, JavaScript, JPEG, or MP4. Subtypes may also contain tree prefix like VND, which stands for vendor or producer. Say Amazon Kindle ebook format or MS PowerPoint, even MS Excel format. These are some examples of vendor-specific media type. So, vendors or producers, they can have their own custom media types. Now, this can be further extended by suffix. Suffix can additionally specify the underlying structure of the media type as well. This allows for generic processing based on structure and is independent of the underlying data model semantics. This is what we leveraged for our weather forecast example. And this can be further extended to support XML format. At the end, we have an optional parameter, which can be used to specify additional modifiers like language, character set, quality, etc. As you can see, media types are quite powerful and can immensely improve the quality of your RESTful APIs. Hopefully, this video gave you some good insights on what, why, and how of media types, and you'll be able to leverage this knowledge in designing your RESTful APIs. If you have any doubts or suggestions, you can leave them in the comments below. Thank you for watching. Do like and subscribe my channel for more upcoming videos.